Module 1, Topic D, Triangle Congruence. In this topic, we are going to be proving theorems about triangle congruence. And once we know that our triangles are congruent, we will be able to make conclusions about their other corresponding parts. Because by definition, corresponding parts of congruent triangles are congruent. And we're going to refer to this as CPCTC. Another fun one. And you are welcome to write out corresponding parts of congruent triangles are congruent, or you can use CPCTC. Now this is not only for triangles. We could also say that corresponding parts of congruent polygons, congruent figures, congruent quadrilaterals, hexagons, pentagons. But for triangle congruence, we use CPCTC. The main idea here is that if your triangles are congruent, then every pair of corresponding parts, this will be sides and angles, will also be congruent. So let's look at an example here. Thales was a Greek philosopher, and he wanted to figure out how to measure the distance of a ship that was out in the bay. And so he got up on his tower here, which very neatly is perpendicular to the ground, and he built himself a compass. He just nailed two sticks together, and he stood up here and he held one of the sticks vertical, and then he looked down the other stick and moved it out until he could see the ship. And then he just turned around and faced inland and told his little unpaid intern to go stand out here. And he looked down the compass again, keeping the same measurement, and told his unpaid intern to go stand where he could look down the line of the compass. So now he knew that these bottom angles down here are both right angles. He knew that these two angles are congruent because he just reflected that angle. He just flipped around. So those angles are congruent. And this line, by the reflexive property, this side of our triangle is of course congruent. And we need some labels on our triangles here. Let's look at the proof for this. We know that angle TRS and TRL are right angles because your building's perpendicular, hopefully. Makes it much nicer to live in. And angle RTS and RTL are congruent because we just reflected that over with our compass. And he wants to prove that RS and RL are the same. So we've got our given angle. We use the reflexive property for the tower that he's standing in, that side of the triangles. We know that the tower is perpendicular to the ground, so we are given that those are right angles. And those angles are going to be congruent because all right angles are congruent. This is going to be a new theorem for us. So we can prove that our triangles are congruent, and we will see the angle-side-angle postulate coming up. So if our triangles are congruent, then all corresponding parts of your triangles are congruent. So he knew that however far away from the tower his unpaid intern was, that's how far the ship is out to sea. Some postulates and theorems for us. You remember our good friends, linear pair postulate. If your angles form a linear pair, then they are supplementary. And by definition of supplementary, we can say that they add to equal 180. Another good friend, vertical angles theorem. Vertical angles are congruent. One of our better friends. And some new theorems for us here. Vertical angles theorem is just a special case of the congruent supplements theorem. So this says if two angles are supplements of the same angle or of congruent angles. So let's look what we have. We know that angle 1 and angle 3 are supplements, and angle 2 and angle 3 are supplements. So this says that the measure of angle 1 plus the measure of angle 3 equals 180 degrees. And this says that the measure of angle 2 and the measure of angle 3 equals 180 degrees. What's common to both of those? Angle 3. So we know 1 and 2 must have the same measurement. So let's look at an example. If this measures 100 degrees, then we know that angle 1 has to measure 80 degrees. And we know that if angle 3 measures 100 degrees, angle 2 has to measure 80 degrees. And if your measures are equal, then your angles must be congruent. And along those same lines, the congruent complements theorem says that if two angles are complements of the same angle or of congruent angles, then your angles are congruent. And this is the same idea. We know that the measure of angle 1 plus the measure of angle 2 are 90, and the measure of angle 3 plus the measure of angle 2 are 90 degrees. Then angle 1 and angle 3 must be the same angle. So let's look at this. If angle 2 is 60 degrees, then we know angle 1 has to be 30 degrees. And by the same thing we did before, 3 has to be 30 degrees. If your measures are equal, your angles are congruent. Just definition of congruence. And one of my favorites, all right angles are congruent. This is really an easy proof. Definition of right angle says that measures 90 degrees. Definition of right angle says that measures 90 degrees. If the measure of angle 1 equals the measure of angle 2, then your angles are congruent simply by the definition of congruence. And last, if two angles are congruent and supplementary, then they are right angles. And this should make perfect sense as well. We have two angles. We know that they are supplementary. Measure of angle 1 plus the measure of angle 2 equals 180 degrees. Well, we also know that those are congruent. So if I say the measure of angle 1 is x degrees, then the measure of angle 2 has to be x degrees. And I get x plus x equals 180. Combine like terms, our distributive property there, divide by 2, and x equals 90 degrees. So very simple proof on that one. But some very useful theorems for us here. And finally, some old friends. If our lines are parallel, corresponding angles are congruent. If our lines are parallel, alternate interior angles are congruent. If our lines are parallel, same side interior angles are supplementary. Same side supplementary. And if our lines are parallel, alternate exterior angles are going to be congruent. Now, when we are dealing with triangles and quadrilaterals, alternate interior angles are going to be our friends. If we are trying to make triangles congruent and we end up with parallel lines, the first thing you want to look for, do I have alternate interior angles somewhere? So some good theorems, a fun new reason for our proof, CPCTC. I think we're going to have a lot of fun with triangle congruence.